This is Group Five's presentation. The Group Five included Dana Neuman, Jacob Harrison, and Rebecca Yong. We chose the bank marketing data set, and I'm going to go through the data pre-processing and analysis. So the original data was common separated value in semicolon separation. This was imported. Analysis was done to determine null values, which age, default, and contact had in their data type fields. Information was looked at for the data frames, and the data types were reviewed. Upon review of data types and data, the write-up is included on the dimensions, original assignment, and the changing of the values. You can see we started with filling of missing values with the age group, changing of values to category for job, marital, education. Originally, true and false fields were changed to Boolean type, and after a review during chart creations, it was determined a separate field needed to be created. So those were backed out to objects in a four Boolean type specific fields were identified and created to maintain the consistency for the diagrams. As you can see, we updated the age, so this is showing there's no additional missing values. Contact was updated to category. Empties were filled to unknown. There were, besides the Boolean fields, two additional fields were added, a season value, of which included separating months into winter, spring, summer, and fall, and then also an age group value representing young, middle, and old. A secondary write-up you'll see in the code markdown is describing updates for testing. It's just written in code in markdown in here for the since the data set was already in use within the group. And that concludes for section 1 of data analysis and updates.
My name is Dana, and I will be presenting the data analysis and visualization phase of the project. Our research question is, how do demographic characteristics such as age, job, marital status, and education predict the probability of default among banking clients? Our dependent variable is default. The independent variables we selected are age, job, marital status, and education. I imported pandas and NumPy, then loaded Rebecca's pre-processed dataset. I used the info function to assess column types and data structure. The code separates variables by data type into numerical and categorical. We classified age as numerical. We used numerical variables to analyze central tendency by applying the describe function and transposing the output. Then we added median and mode columns to the summary table. In this data set, the mean age is 41, the median is 39, and the mode is 32. The skewness shows a slight positive skew of age, meaning most clients are younger. We explored kurtosis. Age showed slightly fatter tails than a normal distribution. Next, we moved into visualizations by importing Seaborn and Matplotlib. We plotted the distribution of age by setting the figure size and using Seaborn's hisplot. We chose a specific number of bins and included a line to smooth the data. Next, we calculated the mode of the categorical variables. The mode for the job type is blue collar. The most common marital status is married, and the most frequent education level is secondary. We use Seaborn's count plot to visualize the frequency of each category among our independent variables. We created a correlation matrix heat map. The results showed no correlations worth noting. We filtered the dataset to include only clients who defaulted. grouped them by age, and counted the defaults. Then we plotted a bar chart to visualize how defaults vary across age groups. After plotting the defaults, we calculated proportions to see which groups were most affected. The analysis showed that clients in their 20s and 40s had the highest proportions of defaults, highlighting these age ranges as key risk groups. Moving on to defaults by job type, we found that entrepreneurs, the unemployed, and the self employed had the highest proportions of defaults. Looking at marital status, divorced clients had the highest proportion of defaults, followed by singles. Lastly, we examined defaults by education level. While the proportions were relatively close across categories, clients with secondary education had the highest proportion of defaults, followed by those with the primary education. Thank you. That concludes the data analysis and visualization portion of our presentation. I'll now hand off to Jacob, who will guide us through the final phase of the project.
My name is Jacob, and this is part 3, or the data analysis section of Group 5's final project. So in order to choose a model, there's 2 questions that we need to figure out. One is if it's supervised or unsupervised. The answer to that is that our data is supervised. This is because in our data set, we know whether or not someone will default on their payment. Since we know the outcome, our model will be supervised. And since the outcome is either defaulting or not defaulting, it makes it a binary piece of data. It's either defaulted or not. It's 1 or 0. So we need a model that can handle this. Because of this, I chose 3 different models. The first is a logistic regression model. The second is a random forest model that has much more decision trees. And then the third is a calibrated classifier on the random forest model to help make the probabilities a little more realistic. In order to make the models, you can see here that I had to make dummy variables so that the model could interpret jobs and these categorical data pieces. It'll essentially make a column for each job type, marital type, education type, age group type, and it'll set it to 1 or 0 based on what it is. So if they're a teacher, it'll be job underscore teacher, and that'll be set to a 1. If they're not a teacher, it'll be set to a 0. And this lets the model know who is what. Then we simply make the models. We put in the data, we fit the model, we get our probabilities, we set the threshold using the histograms from below. And then we do the exact same thing with the random forest, fit it, get the probabilities, and the same thing with the calibrated classifier model, fit it, get the probabilities, set the threshold. Now, this is the probabilities for each of our models. You can see here that there's a lot of overlap, which would lead to think that the model performance won't be great because in cases where it wants to guess positive, there's going to be a lot of false positives because you can see all this overlap from the negative cases. Same goes for every model except for the calibrated classifier, where all the positive cases are really close to 0.0 or lower, and all of the negative cases are closer to 1. Using a confusion matrix, you can kind of understand the decision-making process of the models and all the positives and negative guesses it's making. And these are going to be the insights for the random forest model, the logistic regression model, the calibrated classifier model, and then the random forest model. For measuring model performance, I like the accuracy, precision, recall, and F1 score. You can see here that we have a very low accuracy, a really low precision, and moderate recall, or a fair recall for some of them, except the logistic regression has a really good recall. But that doesn't matter because of the low precision. And then very low F1 scores. F1 score below 0.5 probably means that the model isn't good and you shouldn't use it. So a score of 0.03 is very, very bad. To interpret the results, it makes sense that the models are performing poorly because defaulting is a very complex situation and it would require very in-depth and complex data to predict it. By using just things such as job or marital status or age, it's very hard for the model to accurately predict this, and we would want something more complex such as credit history where the model could really get insights into the financial responsibility or behaviors of an individual. And then here we can just look at the variable contributions and how they influence the model and the decision it makes. And so looking at this to answer our research question, we decided that no, you cannot use things such as age, marital status, or job type, or education to predict defaulting with these models. You need something much more complex like credit history. And that is the end of this presentation. And thank you for listening and watching.